IDUNN is a European project funded by the European Commission, which is being promoted to add the trust ingredient to any business by making its ICT systems resilient to cyber attacks. The aim of IDUNN is to create a trustworthy, faster, effortless and productive security shield in the form of tools, methodologies, microservices and initial standards compatible with any ICT supply chain. Under the project, some different technologies have been developed which offer some microservices that will support the objective of the project of making all ICT systems resilient. These microservices are grouped into different technological tools depending on their functionalities to provide a competitive advantage to the EU vendors on security. Solutions: AMORA, HEIMDAL, THOR, ODIN and FRIGG.
At Office we developed AMORA. This is a system based on Gazelle that leverages the original communication testing platform to not only test the communication but also test the software integrity of the hardware components that are comprised of the systems in the use case.
What we have been doing for IDUNN has been that we have been developing the visualization models or visualization widgets for other IDUNN tools. And in this, for example, in the use case of COSINT, we are using AMORA-based information. AMORA is collecting the information from the COSINT use cases, and we are using the AMORA as a visualization provider of visualization data from the COSINT when we are first having and then doing the final implementation based on that.
We introduced HEIMDAL, a dynamic threat detection tool that has been developed as a part of the IDUNN project, with the goal of a real-time, autonomous and dynamic detection of incidents and threats in an operational technology environment. Using the software bill of material of the network devices, vulnerabilities can be detected automatically due to a daily updated list of the most common repositories. Using a virtual EDR based on deep learning technologies, the network traffic is constantly monitored to detect threats.
In the IDUNN project, we have developed a smart phaser, which is a tool that allows to find different kinds of vulnerabilities in the system that we want to test. So the major difference of our phaser comparing with other ones is that we use the physical responses of the system in order to generate the new inputs and to find in an easier way those vulnerabilities.
So ODIN is a component developed inside the IDUNN project that is in charge of the implementation of the cybersecurity responses in the ODIN environment. So this component receives alerts from the different IDUNN tools, for instance AMORA, HEIMDAL and THOR. And once these alerts are analyzed, it can implement automatic or manual cybersecurity responses in order to mitigate these cybersecurity alerts.